Hi, Jada. I thought it might be time for me to record a quick video for you. Probably not going to be particularly beneficial for us to keep going back via email since I sent you a procedure and it didn't seem to click. So what I think I'll do is I'm going to walk through a couple of these problems and show you how to do them on your calculator. And then how do you determine whether it's a z-test or a t-test? Depends on the information that is given to you in the problem. So let's go ahead and look at problem one. Problem one, they do give you the null and alternative hypothesis. The null hypothesis says that the mean is equal to 56.8, and the alternative is that the mean is less than 56.8. Every alternate hypothesis is either less than, greater than, or not equal to. Every null hypothesis contains equality. So it's either less than or equal to, greater than or equal to, or equals. It has to contain equality. I know this is a z-test because they have even highlighted in blue for me that I know the standard deviation of the population is sigma equals 17.5. Since I know that, I know I can use a z-test. All right, so now I'm going to open my calculator. I'm going to go to my tests, and I'm going to put the information for this problem in. Okay, so let me open my calculator. Let me clear out what I have in there. All right, so I am going to go to stat. I'm going to go over to tests, and I'm going to conduct a z-test. Now, since I am given the mean and the standard deviation and the size of my sample, I use stats. If I have data that's in a list, I would put that data in a list and I would use data and tell my calculator what list I have that information in. All right, so your mean that you're testing with your null and alternative hypothesis was 56.8. So I'm going to put that in. And the standard deviation of the population was known, and that was given to you to be 17.5. So I'm going to put that in. Then the mean of the sample that we took, the mean of that sample, they have it capital M, but that is the mean of the sample, and that was 49.1. And in my sample, there was 23 in my sample. Oops, I put that in the wrong place. I just think, oh, get to see me mess up. Let me go back to test. Let me go back to the z-test. Let me go down and fix that. That was 49.1, correct? Delete those two. And the sample size was 23. All right, now how do I decide if I use not equal to, less than, or greater than in this line? It's based on the alternative hypothesis. So if I go back and look at the alternative hypothesis, it is less than. So that is what I'm going to choose. So I'm going to go down there and I'm going to highlight the less than and hit enter. So now I should be good to go. I got 56.8 for the mean that I'm testing against. I have 17.5 for my standard deviation. My mean of my sample was 49.1. The sample size was 23, and my alternative hypothesis is less than. So I'm going to go down and I'm going to hit calculate. And here's the information that I'm looking for. I am testing the hypothesis that the mean is less than 56.8. That is the alternative hypothesis. The test statistic that I get is the z-score here. So z equals negative 2.11016587. That is the test statistic. The p-value is 0.01742. And that's what they're asking for the p-value. Now, what decision do I make? Well, I'm going to compare the p-value, the 0.02, let's call it, let's just round it off for at least the sake of discussion, we'll round it off. I probably want to put, I think they're asking for 3 decimal places in the answer in my open math. So you'll want to do that. But for argument's sakes, for discussion, let's call it 0.02. So let me minimize my calculator. And what's my level of significance? My level of significance is 0.05. So I compare alpha, my level of significance, to my p-value, which we got 0.02. The p-value is less than alpha. And the little mnemonic that we use is, if the p is low, the null must go. So if the p-value is less than your alpha, 0.05, which it is, 0.02 is less than 0.05, I reject the null hypothesis. All right, so I've rejected the null hypothesis. So what's my conclusion? Well, since I'm rejecting the null hypothesis, my data is significant. My sample is significant. So there is sufficient evidence to warrant something. So what is the sufficient evidence? Well, the sample data, I will spit it out, supports the claim that the mean is less than 56.8. So if I reject the null, I accept the alternative. In other words, the data that I collected is sufficient to support that claim. So since I rejected the null, my alternative hypothesis is supported. Okay, so we would choose the sample data support the claim that the population mean is less than 56.8. All right, let's look at another problem. How about this one, number 2? I'm not going to look at all of them, but we'll look at a couple just to get you hopefully started. It's once you kind of get the swing of this, getting it in your calculator and calculating it's pretty fast, pretty easy. A manufacturer of a particular brand of tires claims they average at least 50,000 miles before needing to be replaced. From past studies of this tire, it is known that the population standard deviation is 8,000. So I know I'm going to use a z-test because they tell me the population standard deviation. A survey of tire owners was conducted. From the 30 tires surveyed, the mean lifespan was 48,500 miles. Use alpha of 0.05. Can we prove that the data is inconsistent with the manufacturer's claim? So it looks like you got the null and alternative hypothesis set up correctly. The null being that the mean is greater than or equal to 50,000, and the alternative is that's the contradictory, the opposite, so it's less than 50,000. All right, so let's calculate the test statistic and the p-value. So we're going to use a z-test. So I'm going to open my calculator back up. I'm going to go back to the statistics menu, over to test, and calculate the z-test again. Okay, and again, I'm inputting the statistics because they gave me the data. If they gave me the raw data, I'd put it in a list and I just let my calculator calculate the mean and standard deviation and all that good stuff for me. All right, so the mean that we're testing against is the 50,000. So I'm going to put that in for mu sub 0. And they told me that the standard deviation of the population is 8,000. So I'm going to put that in. That's how I know it's a z-test, because they tell me the population standard deviation. Okay, and the mean of that sample was, what, 48,500? And my sample size was 30 tires. Okay, so do I use not equal to, less than, or greater than? Well, again, go look at your alternative hypothesis. Your alternative hypothesis is less than. So I am going to select less than, which is already selected. So I'm going to go down here and calculate. All right, you are testing the alternative hypothesis that the mean is less than 50,000. The z-score, the test statistic, is negative 1.0297, rounded off to 3 decimal places. And the p-value is 0.15. So that is the number that I want to compare to alpha. Of course, you'll put in 0.1522, however many decimal places the problem's asking for. But we just really need to look at 2 decimals to compare it with alpha. 0.15 is a really big p-value. When you're testing against a level of significance that's typically 0.05 or 0.01, 0.15 is huge. So the p-value is greater than alpha. So what did we have for alpha? It's going to be bigger. What do we say for alpha? 0.05. Well, 0.15 is much bigger than 0.05. As a matter of fact, the larger the p-value is, the more confident we are in the decision we make. And the decision we're going to make is we're going to fail to reject the null hypothesis. And the mnemonic is, if the p is high, the null must fly. So if the p-value is greater than alpha, you're going to not reject the null hypothesis. See what they have in your choices. Number 1, the first choice there, accept the null. Never. When you're conducting hypothesis tests, you never accept the null. That is never a choice for you to pick. So what are we going to do? We're going to fail to reject the null hypothesis. The p-value is sufficiently high, it's bigger than alpha, that we can't reject the null hypothesis. So we fail to reject. So what's the correct decision? The correct conclusion, that is. What my choices here? Let's see what we got here. There's not enough evidence to include the tires last on average fewer miles than claimed. That pretty much is it, I think. There is enough evidence. No, there's not. You're not rejecting the null hypothesis, so there's not sufficient evidence. There's not enough evidence to conclude that the tires do not last on average fewer miles than claimed. There is enough evidence, excuse me, that's not correct. There is not enough evidence to conclude that the tires do not last on average fewer miles than claimed. It would be fewer miles than claimed. Isn't that what we're testing? That they last less than 50,000 miles? There's not enough evidence to claim that. The evidence doesn't support that they last less than 50,000 miles. All right. Let's see, let's look at number 3, and then we'll probably look at 3 and maybe 4. Number 3 is straightforward because they give you the null and alternative, and then you just need to decide what test you're conducting. And just to note, in this particular case, the alternative hypothesis is greater than, and the null is equal, and that's perfectly fine. The null hypothesis must contain equals. So in this particular case, it can be equal, or it could be less than or equal to. It doesn't matter, because what you're actually testing is the alternative. So the null hypothesis can be mu equals, or it could be mu is less than or equal to. They're the same thing for testing purposes. Okay, so what kind of test do I use? Anywhere in this problem, do you see the words population standard deviation mentioned? No. So you're not going to use a z-test. You're going to use a t-test. The other reason is they give you in the sentence there, it says S equals S. S is a statistic. It's a property of a sample. Sigma is population standard deviation. It is a parameter. It is a characteristic of a population. So they're giving you a characteristic of a sample. They're giving you the sample standard deviation. So you're going to use a t-test. Okay, so let me open my calculator up. Let me go to stat, test, and number 2 is my t-test. And I am again putting in statistics because I don't actually have data to put in a list. And what is my data? Well, the mean that I'm testing is what, 68.4? Yeah, 68.4. So I'm going to put that in for mu sub 0. And what was the mean of the sample that we collected? That was 82.7. And the sample standard deviation they gave me is 17.8. And the sample size, we took a sample of 19. All right, so is this not equal to, a less than, or a greater than? Go look at the alternative hypothesis, which is greater than. So we're going to select greater than. And then I'm going to calculate. All right, so my test statistic is 3.052. My p-value is 0.001, which is small. It's smaller than alpha. If the p is low, the null must go. So we are going to reject the null hypothesis because the p-value is smaller than the alpha. Did they give us an alpha? If they don't, we assume it's 0.05. They did. They gave us a 0.05 alpha. So the decision we're going to make is, since the p-value is less than alpha, we're going to reject the null hypothesis. There is sufficient evidence to support the alternative claim that the mean is greater than 68.4. So we reject the null, and then what decision do we make? Well, there is sufficient evidence, so the ones that say there's not sufficient evidence, just throw those out. The test data that you took is significant. It sufficiently proves something. What does it prove? There is sufficient evidence to warrant rejection of the claim that the population mean is greater than 68.4. Yeah. There is the sample data support the claim that the population mean is greater than 68.4. There you go. Okay. That one I'm going to let you give that a try since they have the alternative and the null set up for you. That is a t-test because the standard deviation is given to me as SD, standard deviation. That is the standard deviation of your sample. So that is a t-test. This one, problem 5, you are going to have to put your data in your calculator. So put this in a list. And then when you go to your calculator, instead of choosing, let me go back to stat, tests, t-test. So you're going to, instead of selecting stats, you're going to go over to data and select that. And then you're going to give it the mean from your hypothesis, which is 47. I know I'm moving that all over the place. I was looking to see what your mean was. I could look over here on my iPad. I have it open too. 47. So you'd put 47 in for the mu sub 0, and then whatever list you put your data in, make sure that you tell your calculator where you put your data. The frequency is 1 because you just have one list of data. And then is it not equal to, less than, or greater than? Well, that is based on your alternative hypothesis, which looks like it's greater than. So you're going to select greater than and then calculate it. Okay, it looks like you've got the hypotheses all figured out. And that may be just from guessing. I'm guessing you guessed. I don't know. You may have figured it out. So I think you're probably, why did you pick z-test? This is not going to be a z-test. Again, read the problem. And if nowhere in the problem they tell you that the population standard deviation is blah, then you were going to use a t-test. Here's another one where you have to put the data in a list. All right, I'm going to stop the video now and send this video to you. And hopefully that'll give you a few hints on how to move forward. If you can get the first few problems, I think the rest of these will probably come fairly easy for you. If you have any other questions, though, don't hesitate to send me an email. Bye-bye.